All right, so we're going to continue on here with hypothesis testing using confidence intervals in this section. Again, if you haven't practiced maybe some of the earlier techniques that were done in the past couple videos, I would suggest trying that out. If you're feeling confident and you want to jump into this video right away, by all means, feel free to do so. Again, the great part here is that this should be very similar to what we did back in 9.1. So let's take a look at what we got. The resting pulse rate for 26 randomly selected smokers was recorded. They had a mean of 80 beats per minute and a standard deviation of 5 beats per minute. The resting pulse rates for 32 non-smokers were also recorded, and they also had a mean of 74 beats per minute, standard deviation 6. Both populations are normally distributed. Is there evidence of a difference in the mean pulse rates between smokers and non-smokers? Okay, is there a difference in the mean pulse rates? Okay, so I can maybe go ahead and start to write out some different averages that we're going to have. How about mean number 1 is the average heart rate of a smoker, and mean 2 could be the average heart rate of a non-smoker. Okay, that sounds like a perfectly good setup. And now I can start to think about my hypotheses. So I have an H0 versus an H1. For H0, I can state that mean 1 and mean 2 should be equal. But if the question is there a difference in the mean pulse rates, then I really would claim in my alternative hypothesis that maybe these two things are not equal. And I'm going to have a two-tailed test that I have to work with here. Again, if I'm going to construct, though, a confidence interval for average number 1 minus average number 2, it's helpful to consider the green hypotheses, which would ultimately look like this. And I'm going to start by believing that the average 1 minus average 2 results in 0, meaning, of course, they're the same. Okay, so I'm going to start by listing out the sample evidence and doing the checks. So we'll start with the evidence. Let's see, X bar number 1, that should be the average heart rate for the smokers in the sample. And so that seemed to be 80. The standard deviation was 5. And my sample size there was 26. X bar number 2 ended up being 74. S2 was 6. And N was 32. So I can also compute here my X bar 1 minus my X bar 2. It looks like that's going to be 80 minus 74, so that should be 6. And I can easily see my delta 0 here. Oh, thank goodness, it's just 0. That means this is going to be a much easier question. Okay, I'm going to have to check my conditions to build my confidence interval. I can go check the formula sheet to see what those conditions actually are. So really quickly, if I move to the formula sheet, I can see that down here, underneath my confidence interval step, I have conditions. N should be greater than or equal to 30, or sample differences come from a normal population for each group. Okay, well, let's see. In our question, we were told both populations are normally distributed. So I'll just recopy that. Both populations are normally distributed. Perfect. So once that's done, I've met all of my checks and I'm ready to kind of create my confidence interval. Again, I just have to identify that level of confidence. And since I was given that alpha was 5% in this question, I can keep in mind that all my X bar 1s minus X bar 2s would occur on a number line. Since this is a two-tailed test, that 5% has to get split up between the two tails. So there's 2.5% on the low end and 2.5% on the high end, which leaves the interval, which would fall in the middle, covering 95%. And so I'm going to do a 95% confidence interval. I'll get ready to write out that interval and place it here. Let's see. When I do my interval construction, I can see on the formula sheet, I'm told that I need to do a 2-sample t interval. And if I scroll around for a little bit, I actually find that at my number 0 in my test list. When I hit enter, notice it already has a lot of the data from previous problems in here, and I need to update that. My confidence level is not supposed to be 98. I want it to be 95. I'll still always select pooled as no, and I'm ready to calculate. Looks like the interval that I'm going to construct is 3.1063 to 8.8937. So that looks perfect. Again, I'm keeping in mind that I'm believing age 0 is true. And age 0 said that I believe that when I do the difference of the two averages, I should get 0. But my interval says that based on the evidence, I think that the difference of the two averages should be somewhere from 3.1063 to 8.8937. So it seems like the believed value of mean 1 and mean 2 is most certainly not in the interval. And I write the following conclusion. Since the interval does not contain the believed value of mean 1 minus mean 2, which was 0, we reject H0. It doesn't seem like a good fit anymore. That said 0 should be a number in the interval, and we didn't get that. So, therefore, we have enough evidence to believe, I guess, whatever H1 says. So I should have enough evidence to believe that there is a difference between the average heart rates of smokers and non-smokers. There we go. Again, hopefully this seems very familiar to what we've done in the past sections when we dealt with confidence intervals. Not much here has really changed. Okay. I would encourage you again to go try to practice these ideas in the associated worksheets. And of course, if you have questions, ask me during our virtual office hours. The next section will be 9.3, where we're going to talk about two means, but from dependent samples. And this will be our last video.